So without wasting time, let us try to cover as many number of topics today. Because tomorrow onwards there is an examination called additional test. Fine. So all the best in advance. And I think last time we have discussed about the construction and working of DC machine. Fine. So in connection with this, let me start with the various types of machines, and then we will a little bit discuss about AC machines also. Right? Okay. So let us quickly revisit. Uh, I hope the screen is visible now. So
Yes,
we
sir.
have seen, yeah, we have seen that the construction of DC machine, and then the magnetic field which is created with the help of this magnetic uh, field poles, which is are on stator, and whenever the conductor is placed or cut, the magnetic flux and EMF is induced. That's what we have discussed. Fine. And also we have seen the working of DC motor, and then construction also we discussed. So let me quickly revisit. This is yoke, field poles, field winding, clear. And we know that the function of each part in detail we have discussed. Now the yoke is the outer cover which provides the mechanical strength and supports the poles which are mounted inside periphery, clear. And the yoke is made up of cast steel material, or sometimes it is a rolled steel material also. Then we also discussed pole and pole shoes. So this is pole shoe. We know that the function of pole shoe is to spread the magnetic flux uniformly into the air gap, and the winding is there. Fine. So this is a pole which is riveted or screwed with the help of screw. So there are certain screws are available which can be fixed inner periphery of your yoke. Then also we discussed about the field coils. So these are the field coils, clear. And these field coils are wound on the poles, each pole. So here there are 4 poles. You can visualize that there are 4 different windings are there called field windings. Okay. Armature core. Also we discussed about the armature core. Fine. So slot is there and the winding is wound on with the help of the slots and teeth. Clear. Okay. So armature core, armature winding, commutator. We also know the function of commutator, which converts AC into DC for generator, as well as because we are giving supply DC to the motor, so that DC is being converted into AC for motoring condition. Okay. So for generating and for motoring, the function of commutator is the rectification. Then brushes, the function of brushes is again to collect the current from commutator, and then it is being transmitted to the stationary circuit, which is connected to the load. Yeah. And bearings. So the purpose of bearing is to rest your whole rotor, which is on the axle shaft. Okay. So these number of various parts we have discussed previously. Then let us discuss about the classification of DC generator. Clear. So as per the connection, this self-excited and separately excited DC generator. So most of the generators which are classified as self-excited generators. So are of having different types: DC shunt generator, DC series generator, and DC compound generator. And again, compound generators are classified into 2 different categories. One is long shunt compound generator, and another is short shunt compound generator. Right? And according to the various applications, these various generators are classified. So let us see one by one, and then we will discuss. Now, classification of motor. So again, self-excited, because the construction is common for your generator as well as motor. Fine. So the classification will be based on the connections of series field winding or parallel field winding with the armature winding. Clear. So again, it is DC shunt motor, series motor, and compound motor, long shunt compound, and short shunt compound motor. So these are the various classifications of AC and DC, DC generators and motors. Fine. Okay. Now, based on this, we are having, just a minute. Just a minute. Is screen visible now?
No, sir.
Just a minute. Just a minute. Okay. Anyone that I'm going to use? I don't want to use any. Okay. So let us discuss the various connections of DC shunt generator, series generator. Shunt means it is a parallel connection. So there is a field winding, F and double F. So these are the terminals. Because it is a DC machine, there are terminals called plus and minus. So F is considered as plus, F double F is considered as minus terminal. Clear? So here, this winding is being connected with this armature called A for generator. So if it is generator, then if it is connected in parallel, then it is known as shunt generator. And here the terminal voltage V can be calculated. So whatever the EMF is induced, E, clear. And because of that current which is flowing IA current will be ISH current as well as IL current. So ISH, that is a field current, or sometimes it is field current is also written like IF, or shunt current flowing through this. So whatever the EMF is induced and the current flows, part of the current is used for field winding, and the remaining current which is flowing through the load which is connected here. Clear? So here, whatever the EMF is induced, and hence the similar current is used for field winding. So here it is named as self-excited. Self-excited. We know that there is a residual magnetism. If you look at the BH curve characteristics of the material, there is a some. So when we increase the H intensity, B is also going to be increased, and this flux density will be increased, and it will be saturated after some time. After increasing as many intensity, there is no change. So flux density will be saturated, and once it is reversed, then again it will not be zero, but it will stay at certain. So there will be a residual magnetism, and this residual magnetism is used initially for this purpose of a rotor. So here in this case, when the current flows, so self current, which is generated or it is abbreviated as IE, armature current, is used for field winding to to become an electromagnet for stationary magnetic field. So this is self-excited. In DC separately excited generator, where the supply is given to the field winding separately and this rotor separately. So in this case, the supply is given separately, and that is why it is considered as separately excited generators. And in self-excited generators, because of their own residual magnetism, So use of this residual magnetism for initial condition, and then when the EMF is induced, because of that, the field current will flow. So here, in case of this generator, we can write the equation of E is equal to, or sorry, IA. IA is equal to IA is equal to ISH, that is a field current, or sometimes it is field current plus load current. Clear? And in case of motor, here it will be different. So suppose if the terminal voltage is given to both the windings, fine. So the current will flow, I current. That current will be divided into two parts. One is flowing from this junction, that is IF or ISH, and another current will be inside the rotor, or IA current. Fine. So this IA current. So in that case, we can write for motor, we can write I is equal to IF plus IA for motoring action, and this is for generating action. Clear? Now, based on the connection, again, series motor is there. So this is a series motor where the armature winding AAA and field winding FFF both are connected in series. So according to the connection, you can see the amount of current flowing through is IA. The similar current will flow through this field current IF, and again similar current will flow through the load. So this is the connection, series connection. So here we know that the amount of flux, because flux is, torque is proportional to phi Ia. Fine. So if you want to increase the torque here, either you can increase the flux or you can increase the armature current. Fine. So this flux that can be generated with the help of current IF, field current. Clear? So here you can imagine that the torque which is produced here, so phi is IA, IF, and this is IA. So can we write IA square here, because this current and this current are similar. So torque is proportional to the square of the current in case of series generator. So here, if the current is more, the torque is more. And the application of such kind of series motor is a ropeway. Right? So initially we need to have a higher torque for a ropeway where the DC series motors are used, even in lifts. So these are the various applications where such kind of DC machines, DC series motors are used, where the torque requirement is more. Such kind of machines are used for various applications. And there are certain applications where we need even speed, variation of speed. So here, by changing, so suppose if there is a shunt field winding, so this is a shunt field wind and shunt motor. Clear? Shunt generator, say for shunt motor, say for an example. Clear? So here, by inserting the resistance here, we can change the current flowing through this, and according to that, we can change the speed also, because whatever the EMF is induced, that is phi Zn P by A upon 60. So this is an equation. So induced EMF for generator or for motor, that is a back EMF. So that flux is directly proportional to here. Right? So here in this case, to increase the speed or to decrease the speed, this is a speed in RPS, because it is divided by 60 here, or if it is in RPM, it is N, phi Zn by P by A. Right? So this is an expression which you do not need to remember, but for your understanding purpose, I am just sharing this here with. Okay. So by inserting the resistance into the field winding externally, because we are connecting all these F and FFF and A and AAA terminals externally. So while connecting this, we can insert the resistance and we can change the field current flowing through that, and we can vary this flux. And similarly, we can also insert the resistance or rheostat into in series with your armature circuit also. So we can also vary the armature current. So DC machines are very popular where by inserting the rheostat in the circuit, both the circuits, either your uh, stator circuit or rotor circuit. Clear? We can control the speed either side. So if the rated speed is 1500 RPM and if you want to run the motor at 100 RPM, that could be possible. And even if you want to increase the speed, that can also be achieved with the help of two different rheostats connected in series with this circuit. So we can have the wide range of speed control of various motors, right? So if you want the various speed control, wide speed control range, and if you want some superior torque, right? So where compound motors are come into the picture. So compound motors are a hybrid motors where we can say long shunt and short shunt compound motors. Dear students, this chapter is not for your additional test. So it is not covered in the additional test, but your semester end examination where this chapter is going to be helpful to you. Only theories. Fine, no need to work out for equations and numericals or examples related to this topic. Only theory which we are discussing right now, working principle, the construction, various types of machines, electrical machines, then uh, we can say DC machines and AC machines, right? So we will little bit discuss about AC machines also. Clear? Now, what is long shunt and short shunt? The meaning itself says that whatever the shunt or parallel connection is a long. So here, this is your field winding AFFF and part of field winding which is connected in series with this armature winding also. So this is a long shunt generator. You can consider it as F1, F1, AA. So two different field windings. One is connected in series to achieve the characteristics of series motor, and again it is connected in parallel to achieve the characteristics of shunt motor. So this is a long shunt. And what is short shunt? Short shunt. So again in short shunt, the winding which is wound to the generator. So this is your voltage F1, F1. This is AA, and here it is connected this winding. So this is FFF. Now you can consider as this as a shunt motor. This portion is a shunt motor. This one, and again this whole shunt characteristic is again connected with the series field winding, and here it is a long shunt. So your combination of series field winding and armature winding is again connected with the field winding. It is a long shunt winding and this is a short shunt winding. So in examination, if it is asked, you can draw this and we can opt this kind of machines for both the different characteristics of shunt as well as series. So it is a combination of both the series here. Done. So these are the various machines. Now let us discuss about AC machines. Now AC machines are of two different types. One is induction machines or induction motor or generator, and the second one is synchronous motor, synchronous, synchronous motor or generator. Okay, so this generator, AC generator, which everywhere in the powerhouse, we know that the electricity is generated, all are synchronous generators. It is also abbreviated as alternator. Alternator. Clear? Now, in industry, these induction machine are widely used because of the availability of AC supply. In DC machine, we have to make an arrangement for DC supply or DC rectification circuit, because from our electricity board, we always receive AC, alternating voltage and current or power. Clear? So if we want to use DC machines in our industry, we need to have some rectification circuitries for conversion from AC to DC, and that DC can be utilized. So additional cost of that rectification. Now for 230 volt to 5 volt and 15 volt, the adapter cost, we know that it is of around 150 to 200 rupees. Clear? But in large amount of current, if we want to transfer, I mean, from AC to DC, we need a lot of electronic component circuitries also. Because here the amount of current flowing through is 1 milliampere, maybe 1 ampere maximum through your charger. But in case of industry where thousands of current ampere is flowing, and for that we need to have some circuitry where we can rectify with the help of power diode circuitries. We have studied diodes, right? Where power diodes are also there. Power diodes. So these power diodes are used for rectification in DC. So this is an additional cost which you have to bear for operating DC machines. But induction motors, if you look at your premises, submersible pump in the water tank, that is AC machine. Fan which is on top of your head, where there is a AC machine. All these are induction machines because it directly operates through AC machine. Now, AC supply are of two different types. We know that one is single phase supply and another is three phase supply. So according to the supply system, these motors are also categorized. One is single phase induction motor, or three phase induction motor. Now, why the name is given induction motor in DC machine and in AC machine? Let us see and let us have the difference first of all. So DC machine and AC machines. Now, what did we do in DC machine? Suppose if this is a stator where we give the supply, DC supply plus or minus to the stator circuitry. So this is a stator. Clear? Also, we give the supply to the rotor with the help of commutator. I'm talking about motor right now, right? So DC supply is given here, and one commutator is used here because we need to convert this supply, or we need to give supply to the rotor also. So it is AC now. Clear? So two different types of magnetic field created is what we discussed previously. So one magnetic field which is created with the help of this DC supply given to the stator, and another supply which is given or conducted to rotor circuitry also. Clear? So our ultimate aim is to create two different magnetic field, and the interaction of these two different magnetic field will exert a torque. So the torque will be exerted here. Clear? So this DC machine where we need to have additional circuit of commutator as well as brush and slip rings. Now in AC machines, the supply is given three-phase for, say for an example, R, Y, and B. Three-phase supply is given to the stator, but in rotor, the supply is not given. Supply is not given to the rotor. So this is the difference here. Here, we are conducting supply to the rotor circuitry by means of some commutator and brush arrangement, but we are not giving any supply to the rotor circuitry. But the construction of this rotor is made in such a way that the EMF is induced in it, and hence current. Clear? Here in DC machine, we are giving supply to the stator for field winding, and we are also giving supply to the armature, which is a rotating part. So sometimes DC machine is also known as conduction machine. Why conduction machine? Because we are conducting a supply to the rotor here, but here some mechanism is done in such a way that the EMF is induced inside. So here EMF is induced, and hence again because of that induced EMF, there is a certain arrangement through which again the current flows inside the rotor bars. So the current flows. So this current here we are giving externally, here we are inducing, and hence we are inducing. The name is induction motor. Clear? So the magnetic field which is created with the help of this supply given to the stator, and the magnetic field due to the current flowing through this. So again interaction of these two different fields, there is a torque exerted. In the circuit. So why it is called induction motor? Because in rotor circuit we are inducing the current, we are inducing the voltage, and hence no need to supply current or voltage to the rotor circuit in induction motor. So the construction is very simple because we are giving supply to the rotor stator circuit only. And here in this case, we are giving supply to the stator as well as rotor both. The purpose is same of torque production. But here in this case, the applications are different. So for low torque applications like a fan or submersible pump in our premises, or if you look at any small industries where you will find this kind of in AC motors, because we need to give supply directly to the stator, and the EMF is induced in the rotor circuit, current is induced in the rotor circuit by some mechanical design, right? So there is no need to have supply given to that rotor circuit, and that is why it is known as induction motor. And DC motor, sometimes it is also known as conduction motor, because we are conducting externally the DC supply to the rotor circuit. Clear? So what are the advantages here? No need to DC supply here. That means economical. The construction is very simple because here the commutator is an additional circuit where the brushes which are mounted on this, but here we do not need such kind of commutator circuit or kind of brushes to be hold on this. Fine. So the construction is very simple. The cost is very less compared to DC machines. AC supply is available easily at our premises, and DC supply for which we need some rectification circuits to convert AC into DC. Clear? So these are the various benefits of an AC machines, and that is why AC machines are very popular. Clear? Okay. So what are the different types of AC machines? One is induction motor, and another is synchronous motor. Synchronous, synchronous motor. Clear? Okay. Now let us look of induction motor. The construction wise, both the motors are similar. So when a three-phase supply is given to the induction motor R, Y, and B, clear? Then suppose if there is a single phase induction motor, then R and neutral or phase and neutral is given to the induction. Okay. So in this case, when three-phase supply is given, we know that the voltages which are 120 apart from each phase difference electrical degree 120 degree each, right? So what happened, due to that there is a revolving magnetic field is created because of this phase difference. So revolving magnetic field is going to be created, and the rotor which is a construction in such a way that the EMF is induced in it because the conductor is stationary and the rotating magnetic field. So for inducing an EMF, there are two different conditions: either a magnetic field where the conductor cuts, or a current carrying conductor is placed in a magnetic field. Then obviously the torque is going to be exerted. Fine. So similarly here, the rotor circuitry where the heavy copper bars are inserted, and these copper bars are short circuited at the end. So whenever, according to the law of electromagnetic induction, again EMF is going to be induced, and this EMF, because of short circuiting of these conductors which are on the rotor circuitry, the current, short circuit current will flow. Short circuit current will flow, and this short circuit current is little higher. So instead of wires, copper bars are inserted for AC machines rotor, and these copper bars are having a thick diameter compared to your another conductors. Clear? So here EMF is induced, the current flow because of all these bars are short circuited, and hence the current flows. So this current is again having their own magnetic field. Clear? So there is own magnetic field, and hence the induction motor works. I hope you understand this meaning of AC machines. Why it is called induction motor? Why it is called induction motor? So the definition is very clear now. Why DC machines? Where stator and rotor both are supplied externally. In this case, only the stator is supplied, but the rotor in which arrangement is made in such a way that the EMF is induced in it. Clear? Okay. So I think it's enough for this electromechanical subject. Sorry, electromechanical energy conversion topic. Fine. So that's all from my side. Do you have any questions or any queries? You may contact at any time, or you can ask right now if you have any kind of technical, non-technical issues, queries, whatever you have. Please discuss. Anyone? Any question? So I hope you have enjoyed last 3 months with my maybe interesting or boring. I don't know, but the lectures which I conducted might be helpful to you in the future. So thank you very much, students, and you may contact for any kind of preparation, and all the best for your examinations. Fine. So thank you
Thank you,
for
sir.
attending the lectures. We'll
Thank
meet
you.
again. Yeah. So I'm sitting in D block D104. So as and when you are on the campus, we'll definitely meet with a cup of tea, and we'll share our experiences here. Fine. So I don't know when it is going to be offline, but yes, if it is, you will receive the email from the university, and then we will discuss.
Thank
Anything
you, sir.
else?
Thank you, sir.
Okay. See you. All
Thank
the
you,
best,
sir.
and thank you very much.
Thank you, sir.
Thank you, sir.
Yeah. Welcome.
Thank you, sir.
Welcome.